Number 17, and this is considered a difficult question. The seating capacity in each section of the auditorium is proportional to its area. What proportion of the seating is in one wing? Now, I'm going to show you two ways to do this problem. And I'm going to show you the mathematical way first. This is not the way I prefer, but I'm going to show it to you because that's what I'm supposed to do. So remember, here's the drawing, and we are looking at the seating capacity, so we're not talking about the stage. I'm going to cover that up if I can, right there. So we are looking at this yellow place and the blue place, and we want to know the areas of those. So I know the blue ones are the same shape and size, they're just facing different ways. So if I find one of those, I can handle this just fine. All right, so the area of a triangle, this is a little bit harder to do than the area of a square or a rectangle. But let's work it out here. So the area of a triangle is 1/2 the base times the height. So I would take the constant 1/2. The base of these triangles are 30. The bases are 30. And the height is 150. So let's say 1/2 of 45 with 2 zeros. And I am going to use my calculator. I believe it's 2250, but let's be sure. I do not trust my mental math. 1/2 times 4,500, yes, is 2250 square feet. That's for one triangle. And we have two triangles. So 2250 times 2 is that 4,500. So we have 4,500 square feet of seating space for the triangles. And then I need to find the area of the yellow section. And that's length times width. So that's going to be 60 and 150. The longer side is 150 times 60. So I believe it's 9,000, and it is, square feet. So that is for the yellow section. This is a very large auditorium. This is some serious seating. So we're going to say 9,000 plus 4,500. And that's going to be 13,500. Let me double check. It's late at night. It's after midnight, so I don't trust any math I'm doing at this point. Yes, 13,500. So that is total square feet. And let me make that a different color. I'm going to do that in red because that's an important number for me to remember. Okay, so we've got that far. Now we need to get a fraction. All right. And that's where we have to do a little bit more reading, or I do. And I'm calculating. I think I messed up. Maybe. If you notice something weird at this point, it's because I was talking away and it was not recording. I think the last thing you heard me say is I think I had miscalculated something and I was working on that and lost the feed. So I'm sorry. I'm just going to pick up where I left off. I had not miscalculated, but I needed to know that before I carried on. The seating capacity in each section of the auditorium is proportional to its area. What is the proportion of the seating in one wing? So what we need to know to get our fraction is one wing over the total area. We know the total area is that red number. That's why I needed to be sure I was okay with that. One wing, that's one triangle. Not both of them, although we had to find both of them to get the total. We need to know one triangle, and that is, of course, 2250. And if you type this into your calculator as a fraction, 2250 ABC 13500 equals, you will get 1/6. And that is the ratio we're looking for, the proportion that we're looking, or the ratio. It is 1/6. Each wing is 1/6 of the total seating. Okay, I want to show you this if I can without making a mess of it. And I'm going to crop this down. I did not solve this problem by doing all that math. I understand that that's what they want us to do, and I showed you how to do it. But there is another way. I'm very much a visual person. I can figure things out by looking at pictures much easier than I can reading words. So let me show you something here. And I wish I could literally manipulate this around, but I can't. Can I? Let me think. Okay, bear with me here. I'm going to take out this writing that says wall A. I want to cover that up with something else. So what if I were to take this triangle right here, take it off, and bring it over here so that I could line it up with this triangle. Now let me say that again. I'm going to take this blue triangle right here, and I'm going to cut it off. Actually, let me do this one. Let's take this blue triangle and bring it over here. Okay, so let me draw that in there, and then I'll cut this one off. So it'll just let me cut it off already. So I'm going to cut it off of here. Like so. And then I'm going to draw it in. I'm going to bring it right over here. Let me do it with a dark pen. I'm going to bring it right up here and lay it in this way. Okay, do you see it in there? Let me make it a different color. If we were in an actual classroom, I would have you do this with paper triangles so you could see it. But I'm going to bring it right down in here. So I cut it off of that side and I moved it over here, and I'm going to show you why. I want you to see why I did that. Now remember that base up here was 30 feet. So this was 30. But I pulled those two triangles in there side by side. The two wings are sitting in there. And remember, this triangle, or this rectangle, is 60 feet across. So this would be 30. I hope I'm not confusing you. This is 30, this is 30, which means that I could fit two triangles in here. And two in here. And how many do we have now? We have 1, 2, 3, 4, 5, 6. So one triangle wing is 1/6 of the whole seating area. That's another way. That's the way I did it. When I first read this problem, this is what my brain saw. But some people don't think that way, and so I had to show you the other way. Either way will get you the answer you want. This one is listed as a hard question for good reason, but you can choose to do it either way.